Section 5.4, Logarithmic Functions. I'm going to start with a question. Your car depreciates in price, p, after x years, according to the exponential function p of x equals 16,630 times 0.9 to the x power. If you want to sell it to make a profit of $8,000, how many years after you purchase it should you sell it? Well, you might look at this and say, oh, well, this is easy. We need to find the x when p is 8,000, the price, right? All right, well, let's set that up. So this will be our answer. 8,000 times, oops, I'm sorry, not times, equals 16,630 times 0.9 to the x. All right, if we go to start solving this, maybe we'll divide both sides by 16,630, 0.9x to the x. Okay, what's our next step? Do we take the xth root? What? What does that mean? Can we do something like that? Oh, looks like we need an inverse function of an exponential function to find the exponent. What is that function? Well, it turns out that there are no combinations of operations, meaning plus, minus, divide, square root, that we can do to, quote, undo an exponential function to find a variable that is an exponent. So there's nothing we can do that we already know how to do? What? All right, so what we're going to do is we're going to define a function. Yeah? We're going to define a function. So let's give it a definition. We're going to call it a logarithm. Yeah? A logarithm is an exponent. Remember, we're trying to solve right here for this exponent to the x. So we want to find an exponent that you raise some base to, right? Our base in this problem being 0.9, yeah? To get some number, right? And in this case, our number that we want to get here is whatever 8,000 over 16,630 is. Now, how are we actually going to define it? Well, we're going to, how are we actually going to find it? So, what we're going to do, I'll show you, okay? To find x, right, we're going to say this. We take the log, which is what we use to abbreviate the function logarithm, of 0.9 to the base 0.9 of 8,000 over 16,630, and that is going to equal x. All right? All right. Okay, great. So I see the variable is isolated on the right-hand side, and on the left-hand side I have, some function of a number, right? Hold on, I'm going to fix this. 0.9. Make it look better. There. I have some function of a number. How do I evaluate it? In the calculator? Ooh, if you look at your calculator, there's this idea of log. Well, turns out that the log in the calculator is base 10. And in this problem, our base is 0.9. So we can't use that. Okay? So if we can't do any operations like plus, divide, minus, take square root, how do we do this? Well, we're going to come back to that later in section 5.5, because the first thing I want to do is talk a lot more about the logarithm and the logarithmic function. Okay, so let's start with an example where we're going to change each statement into its equivalent form using the fact that y is equal to log base a of x is the same thing as, that's kind of, this equals means you can go both ways between these equations. X is equal a to the y. Okay, this is a very, very important thing. In fact, it's the formal definition of logarithm. So let's see what's happening. Over on the right-hand side, right, we have x equaling some exponential function. And the idea is that we can say, oh, well, this y here, this exponent, is equal to the log base a. So notice this base a is the same as this base a. That's not coincidental. Of x. So this x here is the same as this x here. All right. This is a really important definition that you actually need to memorize. Okay. I'm going to back up a little bit. Notice that we originally had this equation, right here. 8,000 over 16,630 is equal to 0.9x. So we have here some kind of number equaling a base to an exponent, over here. Notice we have, and then if we go back here, we have a number equaling a base to an exponent. And then we transformed it to the log of that base of the number equaling the exponent, right? And then take another look right here at this definition. We have the number equals log with the same base of that same number. That's equaling the exponent, okay? A phrase that's really helpful to use, a log is the exponent. Okay, we're going to remember this phrase. It's really, really helpful as we do this switching around. Okay, so let's do a couple of examples. If I want to say 16 equals 4 squared, right? That is the same thing, right, as saying that the log base 4 of 16 is equal to 2. So the idea is I'm saying that the log is, meaning equals, the exponent, right? So the log base 4 to get 16 is the exponent 2, right? And that's exactly what this says, right? Base 4 to get 16 is 2, that exponent, okay? So notice we're going to say here, the log is the exponent, right? I'm just translating this sentence. The log is the exponent. And notice the exponent over here is 2. Alright, let's do another problem. Okay? A cubed equals 2.1. That's the same thing as log. Now what's our base? Oh, I look over in the exponential and I see the base is a. Log base a. And I know that the log is the exponent. Well, what's the exponent over here? It's 3. So that means 2.1 is the thing we're taking the log of. Okay, so it rearranges to that. Let's do one more. C. Log base 3 of 81, if we want to write that instead in exponential form, what's the base? Well, 3 is the base, right? And remember that the log is the exponent. So this entire thing, this log base 3 of 81, I'm sorry, I forgot part of this. Pardon me, let's back up. Boop, 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 boop. Equals 4. Alright? So I have base 3, and remember we say the log is the exponent. So 4 is the exponent, equals 81. Because anytime we see this idea of log, we're saying, oops, since the log is the exponent, this says the exponent we raise 3 to get 81 is 4, right? In fact, you can translate this phrase of log base 3 of 81 equals 4 to this sentence. The exponent we raise 3 to get 81 is 4. And notice that the exponential equation reads the exact same way. All right. Let's do 2 more. D. Log base 3 of 1/9 equals -2. Again, the base is 3. The log is the exponent, which is -2, to get 1/9. And that's true, right? 3 to the -2 is equal to 1/9. One more. Log base b of 4 equals 2. Well, that's the same thing as saying b squared equals 4. This equation, b squared equals 4, oops, close it, collapse, b squared equals 4, we could go on to solve this guy, right? But again, we're going to do that later, because we're going to find out that when we're solving exponential equations, we have to worry a little bit about their domain. Okay? For now, let's do a few other things. We're going to evaluate the following logs. Without a calculator. Meaning we're going to find the exact value, not an approximation. Now you might say, well, we don't even know how to use a calculator yet to do this. I'm going to teach you, don't worry, later. Although, it's better not to most of the time. So we're definitely not going to use a calculator. But I just want to show you when the directions say don't use a calculator or find the exact value, this is what we need. Okay, we have the expression log base 3 of 9. So remember what this means. The log is the exponent we raise 3 to get 9. Well, what is that exponent? What exponent do we raise 3 to get 9? 2, right? Because 3 squared is equal to 9. So this whole expression, log base 3 of 9, is equal to 2. Okay? Let's do another one. Log base 1/3 of 9. This one's not as easy to maybe think of or to rewrite easily. So this is my suggestion. Take the expression you're trying to evaluate and set it equal to a variable, x. Then we'll switch it around into its exponential form. The base is 1/3. Remember that the log is the exponent, so that means your exponent is this number, x equals 9. What do we raise 1/3 to get 9? Alright, when you're working on a problem like this, the idea is that you want to take both sides and write them in terms of the same base. So, can we write 1/3 to the x in a similar base as 9? Well, 1/3 to the x is the same as 3 to the negative x power, isn't it? And 9, I know, is 3 squared. Interesting. Now, notice, if I have two of the same bases that are equal, right, then their exponents must also be equal because these two expressions are equal. So basically, we can just drop their bases, say that minus x is equal to 2, which means that x is -2. Okay? So basically, we're saying that the log of base 1/3 of 9 is equal to -2. Alright, let's do one more of these. Let's take the log of the square root of 3 of 9. Okay, same thing. I'm going to set it equal to x and switch it around, and we're going to say the the square root of 3 to the x equals 9. And I'm looking for this exponent. Well, what's the square root of 3? Square root of 3 is the same thing as 3 to the 1/2 to the x. And I know that 9 is 3 squared. Well, I know that if I raise an exponent to an exponent, I multiply them together. So that means that 1/2 x is my exponent on 3 on the left. Now I can drop those bases, and say 1